Hello friends, in today's lecture we will discuss second shifting theorem of inverse Laplace transform. So let us see the second shifting theorem of inverse Laplace transform. So this is the statement of second shifting theorem of inverse Laplace transform. If L inverse of Fs equal to Ft, then L inverse of e to the power minus As into Fs equal to Gt, and where Gt is defined as f of t minus a when t is greater than a, 0 when t is less than a. So this is the statement of second shifting theorem of inverse Laplace transform. Now the proof of the second shifting theorem of inverse Laplace transform. So let us see the proof. We have, by the definition of Laplace transform, L of gt equal to 0 to infinity integration over 0 to infinity e to the power minus st gt dt. Now 0 to infinity can be written as in two parts, 0 to a and a to infinity. So 0 to a e to the power minus st gt dt plus a to infinity e to the power minus st gt dt. Then 0 to a e to the power minus st gt becomes 0 dt as per the statement conditions, plus a to infinity e to the power minus st f of t minus a dt. So it becomes e to the power minus as into L of gt by the definition using given values of gt. So it becomes 0 to infinity e to the power minus st f of t minus a dt equal to a to infinity e to the power minus of a plus x fx dx, because here on putting t minus x equal to a, so t becomes x plus a and dt becomes dx. So this expression becomes 0 to infinity e to the power minus as e to the power minus sx fx dx. Now e to the power minus as would be outside of integration 0 to infinity e to the power minus st ft dt. Now by the property of definite integral, namely integration over a to b fx dx equal to integration over a to b ft dt, both are same. By using this property, it is written as like this. Now thus L of ft equal to e to the power minus as into fs, because L inverse of fs equal to ft, so L of ft equal to fs. Hence by the definition of inverse Laplace transform, we get L inverse of e to the power minus as into fs equal to gt. This is the required result. Now this is the note of the above theorem. The theorem of this the result of this theorem can also be written as in the following two ways, like this: L inverse of fs equal to ft, that implies L inverse of e to the power minus as into fs, and as we know by the conditions of gt is defined as like this: f of t minus a when t is greater than a, 0 when t is less than a. So this is also another part of the expression of inverse Laplace transform of the result. Now the next part is L inverse of fs equal to ft, that implies L inverse of e to the power minus as into fs can be written as in terms of unit step function f of t minus a, h of t minus a. Here h of t minus a is heaviside unit step function, which is defined as h of t minus a equal to 1 when t is greater than a, 0 when t is less than a. So we remember the unit step function is defined as like this: h of t minus a equal to 1 when t is greater than a, 0 when t is less than a. Now let us see the example related to the above theorem. The evaluate L inverse of e to the power minus 4s divided by s minus 3 of all to the power 4. So the solution is, first of all, let fs equal to except of e to the power minus s. So what it becomes? It becomes 1 by s minus 3 whole to the power 4. So we suppose here fs equal to 1 by s minus 3 whole to the power 4, and ft, as we know by the inverse Laplace transform, ft is L inverse of fs. So this is equation number 1. Here ft equal to L inverse of fs by the first shifting theorem, or ft equal to, ft can be written as, because fs is given 1 by s minus 3 whole to the power 4, so it becomes ft equal to e to the power 3t of t cube divided by factorial 3. So factorial 3 becomes the 1 by 6, 1 by 6 t to the power 3 e to the power 3t. So this is the equation number 2. Now by second sibling theorem, L inverse of e to the power minus 4s into fs equal to f of t minus a when t is greater than a, 0 when t is less than a. So it becomes L inverse of e to the power minus 4s divided by 1 by s minus 3 whole to the power 4 can be written as 1 by 6, because this part we have already defined, 1 by 6 t minus 4 whole to the power 4 e to the power 3 of t minus 4 t greater than 4, because here in place of a is 4 and 0 when t is less than a, that means t is less than 4. By using 1 and 2, we have L inverse of as divided by s square plus a square plus 1 whole square can be written as 1 by 2 1 by 2 1 by a t by a sine of t by a. This is equation number 2, and finally it becomes 1 by 6 t minus 4 all to the power 4 e to the power 3 of t minus 4 h of t minus 4. So this is the required result. This is the not part of this result. So after simplification of this part, it becomes 1 by 6 t minus 4 whole to the power 4 e to the power 3 of t minus 4 h of t minus 4. It is the unit step function in terms of unit step function. Now another example, if L inverse of s divided by s square plus 1 whole square equal to 1 by 2 t of sine t, and find L inverse of 32s divided by 16s square plus 1 of whole square. So given that L inverse of s divided by s square plus 1 of whole square is given 1 by 2 of t of sine t. This is equation number 1. Now written as as in place of s in equation 1, and using the change of scale property, we have L inverse of as divided by s square plus a square plus 1 of whole square. It becomes 1 by 2 1 by a t by a sine of t by a. So this is the equation number 2. What we get? And we get by using the change of scale property of the result. Here in place of as can be written, in place of s we have written as. So it becomes the expression like this. This is equation number 2. Now from the present problem, here we put a equal to 4 in equation 2. So we get ft equal to L inverse of 4s divided by s square 4 square plus 1 of whole square. It becomes 1 by 2 and 1 by 4 t by 4 sine of t by 4. What we done here, we just put the value of a equal to 4 in place of a equal to 4, and after simplification it becomes so 8 should be here. After cross multiplication, 8 of L inverse of 4s divided by 16s square plus 1 of whole square equal to 8 of 1 by 32 t of sine t by 4. Multiply both side by 8, and so it becomes the finally L inverse of 4 into 8, that means 32 s divided by 16 s square plus 1 of whole square equal to 1 by, after cancellation, 1 by 4 t of sine t by 4. So this is the result. Now take the another example related to the above theorem. Evaluate L inverse of e to the power minus e to the power 4 minus 3i divided by s plus 4 whole to the power 5 by 2. So again by the same process, first we take fs equal to e to the power 4 divided by s plus 4 of whole to the power 5 by 2, and ft equal to L inverse of fs. Therefore ft equal to L inverse of e to the power 4 divided by s plus 4 whole to the power 5 by 2 can be written as e to the power 4 L inverse 1 by s plus 4 whole to the power 5 by 2. So it becomes e to the power 4 e to the power minus 4t L inverse 1 by s to the power 5 by 2. So after simplification of this part, it becomes e to the power 4 of 1 minus t, and it becomes L inverse of 1 by s to the power 5 by 2 becomes t to the power 3 by 2 gamma of 5 by 2. So after simplification of this part, and reducing the gamma value of 5 by 2, it becomes e to the power 4 of 1 minus t as it is, t to the power 3 by 2 as it is, and it becomes 3 by 2, 1 by 2, and under root pi. So finally we get 4 t to the power 3 by 2 e to the power 4 of 1 minus t 3 of under root pi. Hence, by the second shifting theorem, we have L inverse of e to the power minus 3s of fs can be written as f of t minus a when t is greater than a, means 3, 0 when t is less than 3. So on substituting in the form of function f of t minus a, it becomes 4 by 3 of under root pi t minus 3 to the power 3 by 2 e to the power 4 of 1 minus t minus 3. What we have done here, because we in previous step we have already defined the function of ft. Ft is 4 of t to the power 3 by 2 e to the power 4 of 1 minus t and 3 of under root pi. This is the value of ft, and we just have to convert it in the form of t minus 3. So it becomes like this. So by using equation 1 and 2, and after simplification we get the result like this: 4 divided by 3 of under root pi 4 minus t minus 3 whole to the power 3 by 2 e to the power minus 4 of t minus 4 when t is greater than 3, and 0 when t is less than 3 here. So in what we write here, we have also written this step in terms of unit step function like this: 4 divided by 3 of under root pi t minus 3 whole to the power 3 by 2 e to the power minus 4 t minus 4 h of t minus 3. So this is the result in terms of unit step function. So thank you. In the next lecture we will discuss the derivatives of inverse Laplace transform. Thank you all.